Hello everyone, this is Energy Crafts here. For over 25 years I've been experimenting and very fascinated with all kinds of energy conversion devices. Behind me is my solar batch hot water heating system, which we will explain to you how to make it and what I think was good about it over a 2-year process. Everyone knows that if you take a pan, paint it black, fill it with water, and let it sit out in the sun, it will get hot. This is the character of converting solar energy into heat, and in this case, the desired purpose is to have hot water. It's extremely simple, and this is how we will go to adapt this principle to a solar batch hot water heating system. Okay, so now I will take you over to a drawing and give you an idea of what it looks like before I show my actual construction. There are many ways to implement a solar batch system. On the drawing I am showing you just my version, and the advantage of my version is I'm strictly using the pressure from the incoming water from whether it's a well or your city water to drive the whole system. In this kind of system, circulation only occurs when hot water on demand is called from a faucet or the bathtub, shower, whatever you're using. And in all other times, the pressure is just maintained in the tanks, and there's no actual flow, no circulation going on. So in my case, we're not using any kind of circulating pumps, electronic controls, computers, or any of that stuff. The whole point of this system is to be extremely simple with no complex things to have to maintain and have to repair in a future time. So I'll explain how it works here and right now. So what you do is you take a tank on the outside of the house, which is here. You tip it to face a south direction from the sun, and the hot water tank will be heated up from the sun, just like the pan that we showed earlier. If the water is hot, the hot water will be at the upper section of the tank, and colder water will be at the bottom of the tank, just for the natural laws of change of density, hot water being less dense, cold water being more dense. So cold water tends to fall. So starting at the beginning, you have your well or city water. It would normally go into the cold inlet of your house tank, but we take a bypass valve so that we can not go to the in-house tank right away, but in fact we go straight to the batch tank outside in the cold input. Once the sun heats up the cold water, the water will naturally rise, and when someone calls in the house for hot water, such as to run a bath, the city water pressure that's on this tank all the time is now going to push this hot water at the top through the line, and in my case I'm going into the drain of the house water heater. When that hot water goes into the drain, being that it's low density, it's going to rise to the top and start filling up the upper sections of the in-house tank. And then it will output from the hot output connection to go to your house usage, like your bathtub or your sink hot water. One might be wondering why I have the batch hot water coming out and going into the drain rather than going up to the rather than teeing into the hot at the top of the indoor tank. Well, the reason for that is a couple of reasons. One of them is is that I want to mix all of this water, since it doesn't mix very well on its own because of the difference of density. I want it to be as overall warm as possible, rather than having a hot layer at the top and a cold layer at the bottom. If you were to take this line and put it up here, then yes, you would fill up hot water at the top, but you would have a natural boundary layer here, and this section of water down here might never actually get heated up, which is okay if you're only using short bursts of hot water. But in my case, I use various amounts of hot water throughout the day and the night, so I want the overall tank to be warmed up. Then one might ask, why even have this tank? Why not just use this tank? Well, one solution to that is 2 tanks is always better than 1. If one fails for some reason, it's easy to just make the bypass, and you can use the other tank. This tank hasn't been modified too much necessarily, and it's easy to put it online if I had to. And this tank has not been modified at all. All we did was we did a bypass here, and we're using the drain. The normal overpressure relief valve is still there intact, and the same also on the batch tank. Another reason to have these 2 tanks is when the cold water comes in and fills the batch tank, the natural sediment goes to the bottom, and you can use the drain that's on that to remove that sediment, rather than letting that sediment go into the house tank and build up there, and then you have to flush that inconveniently inside the house. I have a theory, I don't know if it's true, but I have a theory that sediment is a contribution possibility to why tanks go bad over time versus if they stayed clean. So in my way, most of the sediment would stay in the batch tank, and only a very slight amount might go into the indoor tank. So that's an advantage. So there's 2 advantages of this system. It's not only that we're heating up water as a booster. Normally, let me put it this way. Normally the batch tank is used as simply an assist or a booster for or a pre-warmer to pre-warm water before it goes into your regular hot water tank, so that the electric elements in this would not have to work as hard to heat the water up. Since you might already be, for example, at 80 degrees or 90 degrees, it means that the elements don't have to turn on and burn electricity as long to get it up to, say, 100 if that's where you wanted it. Versus if you didn't have this, you might have 60 or 65 degree water coming out of your main, and when it goes into your house tank, that water you would have to spend the cost of electricity to raise it from the 65 degrees to, say, the 100. But in this case, if the sun has already pushed it up to, say, 90 degrees, then your indoor tank would only have to work for a difference of 10 degrees. So that's an energy savings, and that's the way it's usually done. But in my case, I've totally turned off the in-house hot water tank. There's no electricity going to that between about, I would say, late March or early April, and all the way until now I've been able to get away with it. In fact, starting today, I'm going to have to turn my house water tank back on because this batch tank is not getting hot enough to satisfy me. It's getting it just slightly warm, but it's not getting comfortable if you wanted to take a shower, unless you just like cool showers. So it's still a boost, because when the temperature goes down at 60 degrees at night and the water comes out of the ground at 60, 65 degrees, it's still boosting it up. It's just not boosting it up enough to turn off my heater elements. So starting today after this video, I'm going to be turning this back on, and this will just act as a booster like normal. But all summer long, I haven't had the in-house tank turned on electrically. I've simply have been using hot water made from the sun. So that's the difference between this system and what other people have been doing with a batch system. The other thing that might be a cost savings is it's not just because of electricity, but it's also because of the fact that you have the possibility from the sediment issue that if there's no sediment in this tank, I think that the tank will last much longer. I don't know if that's true because it takes years to prove it, but I think that will be the case. This tank here is already like 12 years old, and I got it for free at Craigslist, so if it fails, it's not that big a deal to me. This tank is 7 years old, and it's at that point where the warranty is over, and it could fail any time. But so I'm curious to see how many years I can go by constantly keeping the sediment removed from the bottom of that tank. Okay, now I'll show you my actual system, and then we'll come back and talk about some of the issues over the last 2 years that I've found that are problems of inefficiency and how you could improve it. But as far as worth it, this system is about as simple as you can get, and it's about as cost effective as you can get. The only cost you really have is to get a used hot water tank, the plumbing, and a few valves. So this tank I got for free on Craigslist. The plumbing cost me very little, probably less than $30, and of course some glue, and yeah, that's about it. It's extremely simple, and it's almost something for nothing thing. I mean, the sun's helping you pay the cost of that electric bill. And as far as cost, I would say that what it saves me is, I would say that it saves probably between $10 and $12 a month during the months that I'm not using this electric hot water element. Now that I'm getting ready to turn that on today, it still is going to be a savings to me every month because the sun always warms that up some. Even on the coldest day of the year, this tank is going to warm up some more than what the city source or the well water is going to be. There are exceptions to that because in the wintertime it's a little bit different than in the summertime, but in general that's the trend. So I would say it saves me, but right now it's saved me about $12 a month. And if you say that's not much, well, look at it this way. It's $12 you didn't spend, and for me, for 2 years, that's enough money saved that when this tank fails, I basically get a free tank paid from the sun because the money I saved in 2 years was enough to buy this tank again. So whenever this tank does fail, I'm going to look at it as if I got a tank for free, because I know this tank's going to fail at some time and I'm going to need to replace it.